All right, so we are going to move into this chapter called Impacts. We looked at observations before in chapter 2, and I've shown several things along the way which are an indication of the impacts, at least in terms of warming and sea level rise and other things. We will focus more specifically here on looking at some historical impacts as well as projections, because we are now mostly worried about what is coming next, and the evidence that exists so far has been compiled very nicely by the IPCC and was presented in in the last AR5 assessment report 5 released in 2014. The depictions in AR6, which is being released now, Assessment Report 6, are slightly different just in terms of organizing the information. So we will go through all these things, including the scenarios, which we have already touched on a little bit. So it's okay, as I said before, to have some re-emphasizing of the messages, so repeating a couple of things here and there should be helpful. So we'll start by repeating anthropogenic radiative forcing as a function of time for the representative concentration pathways that were used in AR5 in 2014 release, and before that in the 2007 release they were called Special Reports on Emission Scenarios. So we are just briefly comparing the two here. So radiative forcing in watts per meter squared, starting at some point in the 2000s and extending out to 2300. There are many projections that continue the model integrations to 2300 because CO2 has a very long life residence time in the atmosphere. So even when we stop, I'm not saying if we stop, we must stop. So when we stop increasing the emissions and go net zero and so on, the accumulated carbon will continue to make large impacts, and sea level rise and glacier melt, for example, will continue, ocean acidification, etc. So some projections are made. Of course, always the big question is the uncertainties in these, and what would we do with this kind of information out to 2300 when we are not able to manage the affairs even for the short time of a decade or two. Okay, but nonetheless, it's good to have some idea of what the future may see. Okay, so the RCP 8.5 and SRES 8.2, for example, are the so-called business as usual scenarios, which would give us fairly massive anthropogenic radiative forcing of up to 12 watts per meter squared by 2300, but even by 2100 it's 8.5. Of course, that's the definition of RCP 8.5. And then you have other scenarios there, SRES A1B. So the way the scenarios were organized in the AR4 were different, with negotiations at a different stage, division of countries at a different stage, equal but differentiated responsibilities, where developing countries were given some room, developed countries were expected to do more, and so on. But Kyoto Protocol, which ended in 2012, I think, or 15, you probably by now can conclude that it was not a big success. Let's hope NDCs or the Paris Agreement does better. So there is RCP 6 and RCP 2.6, which is quite benign, and we want other scenarios down here. They were the SRES scenarios down here, and one of the ones should be 2.6. Yeah, so you can look up the IPCC report for this one, but nonetheless, the IPCC AR5 also put together a very comprehensive map of widespread impacts that could be attributed to climate change, and they did it by taking all the peer-reviewed published reports. So there were given the data, the analysis, and then confidence levels could be put on them. So you see the global map including oceans and all the continents, and the bars here correspond to confidence in attribution to climate change. So very low to very high, and then there is a confidence range given with the gray in some places. And the observed impacts were split into physical systems, which include glaciers, snow, ice, and permafrost, rivers, lakes, floods, and droughts, coastal erosion, and or sea level effects, and biological systems, which included terrestrial ecosystems, wildfires, and marine ecosystems, and human and managed systems included food production, livelihoods, health, and or economics. So impacts identified based on availability of studies across a region. So you can see they were split into North America, small islands, Central and South America, Europe, Africa, Asia and Australasia, and also polar regions like the Arctic and Antarctic. Okay, so outline symbols here, minor contributions of climate change if it is unfilled, and if it is filled, then it is major contribution of climate change. So a lot of information crammed into this figure, but as they say, a picture is worth 1,000 words. So you can stare at these with all the symbols to make sure you get a sense. Of course, the first sense you get is that no part of the planet remains untouched by anthropogenic climate impacts, from the polar regions to every sub-region of the planet, and there are all systems being affected to various levels, and we can say that with various levels of confidence and with major or minor contributions of climate change. So you can see here North America, physical system, biological systems, and human and managed systems are all affected to various degrees. Same with Europe. So you can see the marine ecosystem substantially or majorly affected by anthropogenic climate change. The same goes with biological systems, even in the small islands. Central South America. In many places the confidence can be low because there was not enough data. So you can imagine that data over Europe and North America would be much better gathered since Industrial Revolution, at least because this is trade routes, exchanges, colonization, all those things mattered. Plus, some cultures like China and India had have had a history of documenting things as well. So some regions can be poorer than others in data. Lately colonized or more recently colonized region like Australia, or not so rich in data like South America. The numbers here are the number of studies that were available, and you can also see that in South America there are fewer, Africa, but typically Europe and US have much larger number of studies, similar to Asia as well, and lower in Australasia. Okay, so this gives you a good comprehensive sense of how one can think of impact. So when we talked about observations before, we mostly looked at physical impacts, temperatures, rainfall, soil moisture, and so on. So I will pick a lot of figures from other reports and latest AR6 here to show also impacts, more impacts on ecosystems, sea level rise, glaciers, and so on. Okay, the context, of course, is that excuse me. The context, of course, is that when we look at the ice core data for N2O, which is very noisy, CO2, which is pretty well documented, methane, deuterium is a measure of temperature, and benthic delta O18, which is a measure of glaciation and deglaciation as well. You see the remarkable consistency between them, and of course you remember our asymmetric ice albedo feedbacks in the warming phase, which is quite abrupt, versus the cooling phase, which goes slow because just to remind ourselves, as glaciers begin to build, global mean temperatures get colder, atmosphere's ability to hold moisture gets smaller, and snowfall rates falling, so the glacier builds slower and slower as glacier volumes and extent increase. Whereas in the warming stage, glacier melts, albedo goes up, more energy is kept in the system, more warming, more glacier melt, and this can go very rapidly. We have to repeat this often because now we are in the warming stage in since the Industrial Revolution. And just for context, you can see that the CO2, methane, and temperature, and N2O are the highest in this record, and you can confirm with other records that this is the highest for several million years. And this also tells us again that the temperature is not rising as fast as CO2. Why? Because the energy is going into the ocean in melting glaciers, in evaporating, in raising sea levels, and so on. And this is what we would call committed warming again. So even if you freeze the CO2 emissions where we started at the end of the beginning of the Industrial Revolution at whatever we are now, this figure is a bit old. This says 370 ppm, but we are already at 420 or so. So that accumulated carbon will continue to warm, which means we will get back to this relation between CO2 and temperature eventually. So that's again a reminder of committed warming. So I'll come back and continue with more on the projections and impacts. So we will keep going back and forth in terms of AR5 and AR6 and impacts on different sectors, and come back to AR6 at the end, and then we will get into climate impacts, economic impacts and solutions in the following chapters. Okay, so it's a kind of a good sequence of things coming up.